Hello. In this short video, I'd like to introduce you to the Genie Board and associated software, which I believe is a great educational tool for teaching students the art of computer programming. The board itself comes as a set of components which need to be soldered together. The amount of soldering required is not great and could actually be carried out as part of a design technology project. The board itself consists of the battery pack, the PCB, some resistors, LEDs and the microcontroller itself, and costs about £3.50. This is the Genie Design Studio, which is freely available as a download from the internet. The beauty of the Genie Design Studio is that it is flowchart driven, so the students don't have to learn programming at an early stage, but they can actually put programs together using the flowcharts. In the window here we have our workspace where we create our flowcharts, and on the right hand side we have a range of flowchart symbols which relate to things like digital inputs, digital outputs, analog inputs and outputs, and also a range of features on the board and variables and loops, etc, etc. In order to begin programming a particular board, you need to tell the software what board is actually connected, so you do that through program settings. In this case I have a Genie C14 connected, and as you can see it changes the amount of memory and inputs and outputs available to program. Another great feature of the Genie Design Studio is that it contains a simulation mode. So first of all, what I'm going to do is show you how to create a simple simulation of an OR gate. So an OR gate, as we know, has two digital inputs. So I'm going to bring over two digital inputs, and I'm going to assign those digital inputs as digital input 0 and digital input 1. Also in an OR gate there has to be an output. That output can either be high or it can be low. And I need to choose my digital output. In this case I'm going to use Q5 as my digital output, and again Q5 as my digital output. So now this time the program starts. Okay, it comes down into D0. Is D0 off? Well, if it's yes, it will connect to D1. If D1 is off also, that means both of my inputs are off and I need to drive my output low. So I drive Q5 low. Once I've done that, I loop back round to check my inputs again. If I come round again and D1 happens to be on, driven high, of course one of my outputs will be high, so I can then drive Q5 high. If D1 happens to be off but D1 is high, again as it is an OR gate, that will also drive Q5 high and my output will be high as well. So my program has now been put together through this flowchart symbols. I now want to simulate the program. I literally just press the button here, and what you'll actually see is the program itself will start executing, and the highlighted part shows whereabouts in the program it is. In this case both my inputs are currently low, so the output is also low. I can actually simulate the inputs and outputs as well on the right hand side. So for instance I drive D0 high, what you'll actually see is the program, the flow of control of the program changes and it drives my output high. If I turn off the program, the output, sorry, it now actually goes round. If I now drive the input D1 high, you can see it also drives the program or the output high. Now that was a simulation mode. That's to stop that. What I'm going to do now is quickly download a program to the real hardware to show you how easy that is. In this case I'm going to open a program I've already built called the light sensor. This one is again fairly straightforward. It uses the light sensor which is on the board. The light sensor is an analog input, so this time my program starts. It checks the analog sensor. If there is light shining on the sensor, it takes this route. It just drives an LED high and starts playing a tune. This time it's the Addams Family. To actually change the tune, very straightforward, click on properties. There are some pre-built tunes in, and I can choose a tune that I like. In this time I want to choose James Bond. Okay, loops back round, test the analog device. If there is no light this time, it will drive the LED low and it will actually turn off the tune. To run the program on the device, very straightforward, click on programs, connect to Genie, run live. You'll see on the right hand side here it's actually downloading the program, accessing, and now the program is actually running. So if I now shine a light on my sensor, hopefully you will actually hear the James Bond theme playing. And we do indeed. And if I take my light sensor off, we should see that the LED and also the James Bond theme stops. And indeed it does. That was it. I just wanted to give you a quick idea of what the Genie Design Studio along with the Genie Board is capable of. Say a great thing, flowchart driven. You can run it in simulation without the hardware, but you can actually also run it on the hardware and debug the program in real time on the device itself. Hopefully that was useful. If you have any questions, please let me know. Thank you for watching and listening.